Hello and welcome. This is Michael Annis, and you're listening to episode 70 of the Space Rocket History Podcast. And now, Luna 5 through 9. During 1965 through January of 1966, there were several significant Soviet unmanned scientific missions launched. 5 of them will be covered in this episode. We will begin with the Soviet Moon Program. The Soviet Luna program, occasionally called Lunik by Western media, was a series of robotic spacecraft missions sent to the moon by the Soviets between 1959 and 1976. 15 were successful and accomplished many firsts in space exploration. They also performed many experiments studying the moon's chemical composition, gravity, temperature, and radiation. Each spacecraft was designated as either an orbiter or lander. For this episode, we will study some of the landers. 24 spacecrafts were formally given the Luna designation, although more were launched. Those that failed to reach orbit were not publicly acknowledged at the time, and not assigned a Luna number. Those that failed in low Earth orbit were usually given Cosmos designations. The estimated cost of the Soviet Luna program was about $4.5 billion. You may recall from episodes 15 and 18, Luna 1 missed its intended impact with the moon and became the first spacecraft to fall into orbit around the Sun. In 1959, the Luna 2 mission successfully hit the moon's surface, becoming the first man-made object to reach the moon. Luna 3 rounded the moon later that year and returned the first photographs of the far side of the moon. Luna 4 failed to perform a course correction and missed the moon entirely. Once the early program of guiding a spacecraft to the moon had proved the concept, attention turned to setting a probe gently down onto the moon in order to take photographs and to make limited measurements of the composition of the surface of the moon. These landings needed a more powerful launching vehicle, such as the multi-stage Molniya rocket. Another change was a move away from a direct trajectory to the moon to one where the spacecraft and its final rocket stage were first placed into a low Earth orbit, and a little over an hour after launch, a rocket motor was fired to send the craft into a path towards the moon. Rocket motors aboard the probes themselves were used while en route to the moon to apply small corrections to the trajectory with the aim of avoiding the near-miss scenarios of Luna 1 and 4. In fact, after Luna 4's failure, 2 years elapsed before the Soviets made another attempt for a soft landing on the moon, which brings us to Lunas 5 through 9. The mission for Lunas 5 through 9 was essentially the same. Soft land on the moon, take photographs, make limited measurements of the composition of the moon's surface, and send the data back to Earth. Lunas 5 through 9 all used a similar spacecraft design. The spacecraft was comprised of 2 parts. One end of the vehicle housed the lander, and the opposite end was the conical housing of the retro rocket to be fired just before landing. The spacecraft's total mass was 1,538 kilograms, and it stood 2.7 meters tall. The automatic lunar lander station was a spherical body with a diameter of 58 centimeters and a mass of 99 kilograms. The station consisted of a hermetically sealed container pressurized to 1.2 atmospheres, which held the radio system, programming device, batteries, thermal control system, and scientific apparatus. 4 antennas that automatically opened after landing were mounted on the outside of the compartment. An airbag system to cushion the landing was also mounted outside the station. The entire compartment was mounted above a flight stage which held the main KTDU-5A retro rocket, 4 outrigger veneer rockets, a toroidal aluminum alloy fuel tank, a 90 centimeter diameter spherical oxidizer tank, fuel pumping system, the nitrogen tank for airbag inflation, and guidance and landing sensor equipment. This equipment included gyroscopes, electro-optical apparatus, the soft landing radar system, and small orientation engines. Compartments on either side of the main body contained guidance radar and the 3 nitrogen jets and gas bottles of the attitude control system for use during the cruise stage. These were designed to be jettisoned once the descent was underway. The total propellant load was about 800 kilograms. The scientific equipment comprised a lightweight 1.5 kilogram panoramic television camera and a radiation detector. A mirror on an 8 centimeter turret was mounted on top of the lander above the camera to allow 360-degree coverage. The scientific container was designed to separate from the flight stage immediately before touchdown. The thermal control system maintained the interior temperature between 19 and 30 degrees C. All operations were powered by battery, but there were some small panels of solar cells that recharged the battery slowly by the small current they could produce. During landing, the airbag was inflated like a balloon to provide a relatively soft impact. The main body of the spacecraft had a rod extending downward from the retro rocket section. On contacting the lunar surface, it activated an ejection mechanism to push the lander upwards and away from the spacecraft so it would fall separately to the moon's surface for a relatively low-speed impact, softened even more by an inflated balloon. An offset center of gravity allowed it to roll right way up so that the pedals could open. After touching down, 4 pedals opened out and pushed the spacecraft upright. Rod-type antennas sent data to Earth using the inner surfaces of the pedals as reflectors. A weight cable hung from each rod to indicate the vertical in photographs. The launch vehicle for Lunas 5 through 9 was a derivative of the famous R7. You may recall from last week's episode, the Zond 3 was launched from a Monia 8K78. Lunas 5 through 9 were launched by a Monia M, designated 8K78M. The M version was chiefly created to correct design deficiencies in the third stage of the 8K78 booster. It was first launched in 1964 and had replaced its predecessor, Monia, by the end of 1965. The fourth stage of the launch vehicle was used to fire in orbit to send the payload out of low Earth orbit to its target. And now let's move on to the flights of Luna 5 through 9. On May 9, 1965, Luna 5 was launched from Baikonur. The spacecraft and the fourth stage entered a low Earth parking orbit. At the appointed time, the fourth stage fired to propel Luna 5 towards the moon. After launch and 5 successful communication sessions with the spacecraft, it was time for the mid-course correction. On May 10th, after the mid-course correction, the spacecraft began spinning around its axis and control was lost. The spinning was due to a problem developed in a flotation gyroscope in the guidance control unit that did not have enough time to warm up properly. Eventually, the spacecraft was brought back under control, but at the time of the next maneuver, the main retro-rocket system failed due to a ground control error in calculating the set points, and the spacecraft, though still headed for the moon, was far off its intended landing site. Problems again cropped up with the guidance units, so a retro-rocket burn to slow the spacecraft as it approached the surface of the moon could not take place. As a result, on May 12, 1965, Luna 5 impacted the lunar surface about 700 kilometers from the target, thus becoming the second Soviet probe to hit the moon. A Soviet announcement gave the impact point as the Sea of Clouds at roughly 31 degrees south, 8 degrees west, although a later analysis gave a very different estimate of 8 degrees north and 23 degrees west. With Luna 5's failure complete, we now move on to Luna 6. Luna 6 launched on June 8, 1965 from Baikonur. During the mid-course correction on June 9th, the main retro-rocket failed to cut off as scheduled and instead fired until all of its propellant was exhausted. The problem was traced back to an erroneous ground command sent to the timer. Unfortunately, the overfiring of the retro-rocket put the spacecraft on a trajectory to miss the moon. But in order not to entirely waste the opportunity, the Soviets decided to put Luna 6 through all the procedures of an actual landing, such as the jettisoning of the lander and deploying the airbags, etc. Luna 6 succeeded in the practice run for lunar landing held in open space, but in reality, the spacecraft flew past the moon at a distance of 161,000 kilometers on June 11, 1965. Eventually, contact was lost with Luna 6 at a distance of 600,000 kilometers from Earth. The spacecraft presumably entered a heliocentric orbit. Next up, Luna 7. Luna 7 was launched on October 4, 1965 from Baikonur, but unlike its predecessors, Luna 7 successfully carried out its mid-course correction on October 5th, and its course was correctly set to the moon. It looked like Luna 7 had a good chance of landing on the moon. Unfortunately, immediately prior to a planned retro fire during the approach to the lunar surface, the spacecraft suddenly lost attitude control and failed to regain it. Automatic programming systems then prevented the main engine from firing. As controllers observed helplessly, Luna 7 plummeted to the lunar surface at a very high speed, crashing on October 7, 1965, west of the Kepler crater, relatively near the actual intended target. Impact coordinates were given as 9 degrees north, 49 degrees west. Later investigation indicated that the optical sensor of the astronavigation system had been set at the wrong angle and had lost sight of Earth during the critical attitude control maneuver. Luna 7 was the 10th consecutive failure in the program, including the unreported spacecraft that were never given the Luna name because they failed to reach or leave Earth orbit. And now, moving on to soft landing attempt number 11. Luna 8 was launched from Baikonur on December 3, 1965. This lunar soft landing attempt nearly succeeded. After a successful mid-course correction on December 4th, Luna 8 headed toward the moon without any apparent problems. Just before the scheduled firing of the retro rocket, a command was sent to inflate cushioning airbags around the landing probe. However, a plastic mounting bracket apparently pierced one of the two airbags. The resulting ejection of air put the spacecraft into a spin of about 12 degrees per second. Luna 8 momentarily regained its proper attitude, long enough for a 9-second-long retro-rocket firing, but the spacecraft became unstable again. Without a retro-rocket burn long enough to reduce its velocity sufficiently for a survivable landing, Luna 8 plummeted to the lunar surface and crashed on December 6th, just west of the Kepler crater in the Sea of Storms. However, this mission was not a total failure. Luna 8 did complete the experimental development of the star orientation system and ground control of radio equipment, flight trajectory, and other instrumentation. Which brings us to Luna 9. Luna 9 was launched by a Molniya rocket from the Baikonur Cosmodrome on January 31, 1966. The first 3 stages of the 4-stage carrier rocket injected the payload and 4th stage into low Earth orbit at an altitude of 168 by 219 kilometers. The 4th stage then fired to raise the orbit's perigee to a new apogee of approximately 500,000 kilometers, and deployed Luna 9 into a highly elliptical geocentric orbit. Luna 9 then spun itself up to 0.67 RPMs using nitrogen jets. On February 1st, a mid-course correction took place involving a 48-second burn and resulting in a delta V of 71.2 meters per second. Luna 9 was on the correct course to the moon. On February 3rd, at an altitude of 8,300 kilometers above the moon, the spacecraft was oriented for retro-rocket firing and its spin was stopped. At 75 kilometers above the moon, 48 seconds before landing at a velocity of 2.6 kilometers per second, the radar altimeter sent commands to jettison the side modules, inflate the airbags, and begin retrofiring. At 250 meters from the surface, the main retro rocket was turned on and the 4 outrigger engines were used to slow the craft. At a height of about 5 meters, a contact sensor touched the ground. The engines were shut down and the landing capsule was ejected, impacting the surface at 22 kilometers per hour, bouncing several times and coming to a rest in the Sea of Storms west of Rainier and Marius craters at approximately 7 degrees north and 64 degrees west. After about 250 seconds, the 4 petals forming the top shell of the spacecraft opened outward and stabilized the spacecraft on the lunar surface. Spring-controlled antennas assumed operating positions, and the television camera rotatable mirror system, which operated by revolving and tilting, began a photographic survey of the lunar environment. 15 minutes later, the first test image, which showed very poor contrast because the sun was only about 3 degrees above the horizon, was completed. 7 radio sessions totaling 8 hours and 5 minutes were transmitted, as were 3 series of TV pictures. When assembled, the photographs provided 4 panoramic views of the nearby lunar surface. The pictures included views of nearby rocks and the horizon 1.4 kilometers away from the spacecraft. They showed Luna 9 had landed near the rim of a 25-meter diameter crater at a tilt of about 15 degrees. The probe took the first panorama on February 4th with the sun 7 degrees above the horizon. After the first panorama was taken, the probe slipped as the regolith on the slope settled and was at 22.5 degree tilt when the second panorama was taken. 2 more panoramas were obtained on February 5th and 6th. The pictures included views of nearby rocks and of the horizon 1.4 kilometers away from the spacecraft. The pictures from Luna 9 were not released immediately by the Soviet authorities. Instead, the Jordrell Bank Observatory in England, which was monitoring the craft, noticed that the signal format used was identical to the internationally agreed system used by newspapers for transmitting pictures. The Daily Express rushed a suitable receiver to the observatory, and the pictures from Luna 9 were decoded and published worldwide. The BBC News speculated that the spacecraft's designers deliberately fitted the probe with equipment conforming to the standard to enable reception of the pictures by the Jodrell Observatory. Additionally, radiation data was transmitted back to the Earth, showing a dosage of about 30 millirads per day. Finally, on February 6th at 22:55 Universal Time, the batteries ran out of power and the mission of Luna 9 ended. Luna 9 was the first spacecraft to achieve a lunar soft landing and to transmit photographic data from the Moon's surface to the Earth, preceding the U.S. Surveyor 1 soft lander by about 4 months. The probe also proved that the lunar surface could support the weight of a lander, and that an object would not sink into a loose layer of dust, as some models predicted. In conclusion, it took many failed attempts and 3 years of effort before this part of the Soviet lunar program bore fruit. But eventually, on the 12th attempt, Luna 9 succeeded. Luna 9 was also the first successful deep space probe built by the Lavochkin Design Bureau, which ultimately would design and build almost all Soviet and later Russian lunar and interplanetary spacecraft. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.